Well, this problem is a lot like the problem about the hammer, but the drawing there is a little bit confusing. So what I've drawn over here is just the top one of the two parts of the forceps. So there's the handle, and here's the part that's holding on to the rod, and this yellow blob is supposed to be the rod. So let's draw what's happening here. The top finger is going to be exerting a force in this direction, perpendicular to the line of the forceps jaw, right? So let's call that F sub T. And because the finger is pulling down on this side of the forceps, that means that there's going to be a force on the rod going in the other direction. So let's draw that right here, again perpendicular to the rod, and let's call that force on the rod, F sub R. Okay, the center of rotation is right here at the point P. So now we're ready to draw in our lever arms. The lever arm always goes from the center of rotation to the point of application of the force. So my lever arm for the T force is like this, R subscript T. And I think for everybody that's equal to 8.5 centimeters or 0.085 meters. Then for the R force, the force on the rod, our lever arm is going to go from the axis of rotation P to the point of application of that force, so it's right here. That one is R sub R, which I think for everyone is equal to 2.7 centimeters or 0.027 meters. All right, so we've got our whole diagram here. We've got right angles here and here. Even though it doesn't look like it in this picture, you do push at right angles on a pair of forceps. We've got our two right angles, and we're ready to write some equations about torque. One thing that's slightly confusing about this problem is that it's only talking about one half of the forceps at a time. So you don't have to worry about the other half. It's just the one side. So I drew the top side. So we've got two torques, and our total torque is going to be equal to 0 because nothing's moving here. So our two torques are the torque from the top force and the torque that's on the rod. The torque from the top force over here, this is a counterclockwise torque. This torque over here is a clockwise torque, so one of them has to be negative. It doesn't matter which one's negative as long as they're opposite signs, so I'm going to do it this way. And we still know that's equal to 0. So my torque from the handle part, the F sub T torque, is going to be R sub T, F sub T. And then my torque over here is going to be R sub R, F sub R. And we know this is equal to 0. We know the two lever arms, they're the same for everybody. I've got them here. And then you just put in your F sub T and you can calculate your F sub R.